Okay, so in this lesson, we're going to be solving rational equations. So we've been simplifying rational expressions. Now we're going to be looking at equations. When it asks you to solve it, you're trying to find the value of x. So there's two ways of solving rational equations. One way is by using cross multiplication. It may be used to solve rational equations consisting of two rational expressions set equal to each other. So there can only be one rational on the left side and one rational on the right in order to use cross multiplication. So cross multiplication, you're just cross multiplying both sides, and then you're solving the resulting equation. Always check for extraneous solutions by comparing it to the excluded values that we've been talking about. Okay, so notice we have one rational expression on the left, one on the right. So we can use cross multiplication. So when I use cross multiplication, I'm going to do 5 times x minus 5. I'm just going to go ahead and write it down and then I'll work it out. But you're welcome to go ahead and distribute the 5 to both of those. And then I'm having to cross multiply the other two. So that would be 3 and then x plus 3. So anytime we have two rational expressions set equal to each other, when you cross multiply, they are equal. So I'm going to distribute. So that's going to be 5x minus 25 equals 3x plus 9. Make sure you distribute all the way through. I'm going to subtract 3x over because now I have a linear equation that I'm solving. Add 25. So that's going to be 2x equals 34, so x will equal 17. Now, looking at it, let's look at our excluded values. We don't want x to be negative 3, or looking at the second denominator, 5. Notice x is not either of those, so this would be a good solution. X equals 17. Okay. Next one, notice we have one rational expression on the left, one on the right, so I can use cross multiplication. 1 times x is just x on the left side. And then I have a 3x minus 4 times an x minus 1. I'm going to have to use FOIL here because it's a binomial times a binomial. So don't just multiply the x's and then multiply the 4 and the 1. Can't do that. So I have x. When I use FOIL, that's going to be 3x squared minus 3x minus 4x, and then that becomes plus 4. So notice now that I have a quadratic equation because I have an x squared, so I'm going to set it equal to 0 by subtracting x over. So notice there's negative 3x and negative 4x, but then I have to subtract x. So that's negative 7, negative 8x, and then plus 4. So remember, when you solve a quadratic equation, you can use whatever method you would like. So your choice. You can factor it if you want. You could also use the quadratic formula. So I'm just going to use the quadratic formula, but you're welcome to also factor it or graph it and find the x-intercepts. So I'm going to plug it in. X equals negative b, so that's 8, plus or minus the square root of negative 8 squared minus 4. A is 3, C is 4 over 2 times A. So working out underneath the square root, you should get 16. And then the square root of 16 is 4, so you should have 8 plus or minus 4 over 6. So you have to break that into 2. 8 plus 4 is 12. So that gives you a 2. 8 minus 4 is 4 over 6, which reduces to 2/3. So we have two solutions here. X equals 2 and 2/3. Okay, so we need to look at extraneous solutions. Looking at my denominators, this one here, if I set that equal to 0, so if you can't visually see it, add 4 divide by 3, you get 4/3, so x cannot be 4/3. And then looking at this piece, x cannot equal 0. So those are the two solutions we can't have. Notice that neither of those are those two numbers, so that would be a good solution to have, 2 and 2/3. Okay, so this is one way of solving a rational equation. Unfortunately, we don't always have just one rational expression on the left and one rational expression on the right. So what we're going to have to do if we don't have that is we're going to have to find the LCD, which we've been finding, the least common denominator. Once you find the LCD of all of your denominators, you're going to multiply everything on the equation by the LCD, and then it should be getting rid of your denominator. So that's your goal, is to get rid of the denominator so you no longer have a fraction, and then you can solve the resulting equation. Always check for extraneous solutions because we're dealing with rationals, which is fractions. We can't have a 0 in the bottom. Okay, so first step is to find the LCD. Notice we don't have a denominator on my first term. Second term we do. So this is why we cannot use cross multiplication, because we have this 1 here. It's not just a fraction on the left and a fraction on the right. So factor if possible. We can't factor x plus 1. So remember, to find the LCD, we always bring down the first denominator. I can factor the second denominator, that's difference of squares. X plus 1, x minus 1 multiplied together should give you x squared minus 1. Notice we already have an x plus 1 in the LCD, so I need an x minus 1 also in the LCD. So there's my LCD. We're going to go through and we're going to multiply this by every term on my original equation. So I'm going to start out with doing x plus 1 times x minus 1. I'm having to multiply it. Let me use a different color. I'm having to multiply it by this 1. And then I'm going to, notice there's a subtraction. So I'm subtracting. And then 2 over x plus 1. I need to multiply it by the LCD. And then multiply this one as well. So you're having to multiply every single term on the equation by your LCD. So notice this one here, I need to work that out. When I multiply it, it just gives me x squared minus 1, because if you use FOIL, the middle two terms cancel. And then notice on the second one, x plus 1 is going to cancel. So I need to distribute. Remember, subtraction is tricky. I need to distribute the negative 2. That's going to be minus 2x. And then don't forget to distribute the negative 2 with the negative 1, which would make it positive 2 there. So again, this is a tricky part right here. Always, anytime you're subtracting, always pay close attention. You're going to have to distribute that subtraction sign. And then I bring my equal sign down. Notice everything cancels out completely. So I'm just left with a 4 on the right side. So now I need to start combining my like terms. So I have an x squared. I have a minus 2x, and then when I combine the constants on the left side, I get plus 1 equals 4. So notice this one is also a quadratic equation. So I need to set it equal to 0. So remember, you can use whatever method you want. Since we use quadratic formula on the last one, I'm going to try something different on this one. I'll use factoring. So notice it's a trinomial. Sum is negative 2. Product is negative 3. So that would be x minus 3, x plus 1. And then when you solve using factoring, you have to set each piece of it equal to 0. So x equals 3. And x equals negative 1. Remember, you could have also used quadratic formula. You could have also plugged it in the calculator and found your two x-intercepts. Now, we need to look back up at the top at our original denominators. Notice that we can't have an x equals a negative 1 here. And then noticing here, also a positive 1, where it would cause your denominator to be 0. So looking at our solution, that would, negative 1 would be extraneous, so the only solution we would have on this one would be 3, because negative 1 would make the denominator 0, which would make it undefined. Okay, So solving a rational equation, first check it. If you only have one fraction on the left, one fraction on the right, and that's it, you can use cross multiplication. If not, you need to find your LCD, multiply every single term by the LCD. You should then be canceling out the denominators, which leaves you with no more fractions, and then you should be able to solve that resulting equation. Again, don't forget to check for extraneous solutions when you're dealing with rational equations. If you have any questions, please let me know.